So this is the current carrying loop. So there's a magnetic field, let this be current time, and there's a uniform magnetic field. The magnetic field directed at an angle, let me take 45 degrees. Or the magnetic field, let it be B bar. Let dimensions of this, let it be L. There's a current carrying loop of side length L is kept in a uniform magnetic field where the magnetic field is direct, will make an angle 45 degrees. This is a uniform. What about the torque acting on it? And let m be the mass, let lambda be the mass per unit length of the frame. Okay, we have to calculate it. What about the torque acting, all other, what is the torque acting? What about the maximum angular velocity of this one here? Okay, now you see that there's a current carrying wire, no? It is interacting with the magnetic field. And that particular field what will happen will exert a force. So there must be some interaction potential G. That interaction potential G between the loop and the field is given by this formula. You go back to directly this electric dipole moment U equal to minus P bar dot T bar. Here what you get, M bar dot B bar. So like this will get in a potential. So this is what potential G of current carrying loop. Interaction potential G between the loop and the field. Current carrying loop and the field. And then I will release it. This one, I'll switch on the magnetic field. And then what about the force? Shall we do one thing? Shall we calculate force acting on individual arm? Then we'll calculate the torque. Or shall we directly take a per formula? So according to this, what is the dipole moment? Current I into L square. K cap, Y K cap out of the plane. B bar equal to B cos 45 I cap, B sin 45 J cap. This will be B by root 2 I cap plus J cap. So let me go for torque. M bar cross B bar. K cross I will be J. So this BI L square root 2. K cross I will be J. K cross J. J cross K will be I. K cross J will be minus I cap. So this will be minus I cap plus J cap. Okay, you see that what is the advantage of this? It is telling the axis. So what about this axis? What angle it will make? Shall I say minus I cap plus J cap. So the axis of rotation is what? I'm going to get it. So here, as it is a square frame, this is the axis of rotation. Minus I cap plus J cap. So how the torque is acting in this direction. Sense of rotation is like this. I'll put torque is here. And put term in the direction of torque, curl fingers. The fingers will give sense of rotation. So what will happen to the loop? The M bar, which was along K cap, it will rotate. Next question comes, why do it will rotate? As a current carrying loop, you kept in a magnetic field, and because of that force acting, that force will set up a torque about, what is the axis here? We have X axis, Y axis. I'll call this as PP dash. Along axis, PP dash is what the torque is acting. Able to get this? So this is what happens here. Now next question comes, why do it will rotate? To attain equilibrium. The idea of here equilibrium, I'll bring it because we have interaction potential. You take any system, you take any type of system, either it's a mechanical, electrical, thermal, electromechanical, chemical, the system likes to be in stable equilibrium. And if not in equilibrium, it will try to attain that equilibrium. So the same thing here, the loop, what happened to attain equilibrium, a torque is acting here. So shall I call this like a restoring torque? Yes. So this torque, what I should call restoring torque. Next question comes, what do you mean by stable equilibrium here? How we define equilibrium? Net force, net torque should be zero, and potential G should be minimum. Then that is said to be stable equilibrium. So is it in stable equilibrium? Because torque acting means it's not in a stable equilibrium. How to calculate that alpha, angular acceleration? I'll come to equilibrium later on. Let me find out the other quantities. How to calculate this angular acceleration of the loop? So we know magnitude of torque. What is the magnitude of torque will be? Bi L square. Then what is alpha? Alpha should be torque by moment of inertia about axis PP dash. What should be the moment of inertia about the axis passing through diagonal?
ml square by 12.
So about x and y axis. So you can take help of the this one about x axis. What to calculate is same thing about PP dash also. Or calculate about x axis or y axis will calculate about y dash. About y dash, it will be lambda is mass per unit length, no? 2 lambda L by 2 whole square. What is this 2 lambda? Okay, that I'll write it. Lambda. Okay, what do you mean by 2 lambda? What is the mass of this rod? Lambda into L. Lambda into L. And at what distance it is from y-axis? L by 2. So one L will be there here. Lambda L is the mass. Check it this one. So what is the length of, what is mass of this rod? Lambda L. At what distance it is from y-axis? L by 2. Like that, similarly this side of also. So 2 lambda L by 2 whole square. What is the moment of inertia of this? Because the y-axis will be passing through center of mass. So lambda L is the mass. Length of this side is L. So 2 lambda L square. So if you solve this, we'll get this is lambda L cube by 2 lambda L cube by 6. So 2 lambda L cube by 3. This is moment of inertia y dash. Shall I say it is also equal to PP dash from purple axis theorem? If you can recollect the purple axis theorem. Q dash I y dash please do remember in exams you need not to calculate, better to remember the standard data, and it should be equal to how much? 2 lambda L cube by 3. Substitute that value here, you'll get that instantaneous angular acceleration. What is that alpha we calculated? At that instant, not at all the time. Why I'm bringing word instantaneous? Instantaneous angular acceleration, because look at the torque is mb sin theta, no? As the loop rotates, so earlier what is m bar is along z axis. As the loop rotates, what happened to angle between m bar and b bar will decrease. So therefore torque decreases, alpha also decreases. This moment of inertia will be constant here. So therefore, what type of motion the loop will describe? Variable angular accelerated motion. The alpha will be a function of theta, and what I'm discussing at that instant. So this value is substitute here. So this will be bi L square 2 lambda L cube by 3. So 3 bi by 2 lambda L. Okay, this is the instant angular acceleration. Okay, this is about the basics moment of inertia, what we know, we applied it here. Okay, let's come back to that equilibrium concept, what I wanted. So this moment of inertia, do be aware, different types of loops. So you should be very good in about calculating moment of inertia about the axis. If you go wrong here, I think what all you put effort will be wasted. So you should be very careful about calculation of moment of inertia about the axis of rotation. This is very important in this numericals. And then the equilibrium concept will try to focus. So here first we'll take the loop. Let a current I flowing here.